it's work, sometimes it's okay.
Okay, so the time is yours now,
Yeah,
and I already said we are coming back to experiments and time domain.
Yeah. So I want to share. Can you see me? Everything is okay? The screen. Okay. So welcome everyone. This session I will deliver first of all some introductions to our system which we have installed a few months ago, and then we will go to perform some measurement, and finally after getting the result of the different sample, we will go to analyze the data. So this presentation, this session will include on these three things. So first of all, we have this pen tracker NMR analyzer of resonance system company, and which have a magnet systems probe. Here we install the sample, and this is the electronic unit, and this is the sample temperature control units. So from here, this display, you see what's the set temperature you are setting, and what's the sample current temperature, what's the heaters, what's going on in heater, what's air which are flowing through the hair and magnet. So basically this is the which produce air and flow here, and this is the pressure controller, and from here we adjust the temperature condenser. This is fridge, so we can go here. I mentioned the temperature range of our this equipment, which is between -50 to 150 degree, and we already in the first day you have seen the some other different equipment which is have 17 point something frequency, and the system we have which is like 18.5 megahertz frequency, we will perform our measurement. And now I will go to the next part, which is go to the experiment section. So before you have Maria, I think Maria gave the brief discussion about that how to start up. First of all, I will go from very basic. First of all, you have to turn on from here this electronic unit, and then you will what temperature you want. First, we start from room temperature. You will turn on this from for the air. You will be switch on this, and there's also controller. So you have to turn them, and this is this part. What temperature you want, you can adjust. Here is a breaker, and there is also to turn on this machine, turn on button. So here it's not seen clearly, but the green show us the cooling, how much the cooling is on, it's working or not. So these are something which is we will use these parts to adjust the temperature of our sample. So for after turning off all the parts of the system, we will go to the daily check by using some standard sample like Garris roll, and after we to synchronize, to tune resonance, to check this part. This step is to check that is our hardware is working or not, the pulse calibration is okay or not, what's their range, are there the 90 pulses, because we know that the main difference between the these two equipment like FFC and time domain is that we only perform longitudinal span. Let us experiment in FFC, while in time domain we perform both the experiments. So we need this both type of pulse calibrations. So we will do here. This is the tune resonance, because before we need tune resonance, after I have done this daily check already, and here then we will go in hardware part, we will tune from here. After tuning this, everything is okay, we will go to this option, and the next step, we will upload our sensor. So this is something which is related to the startup. So now I'm coming to the main points, the main issue of our lecture, which is how to measure as unknown sample. So unknown means if you must have the idea that I take protein, I take cheese every day. You must you know about your sample, the name of your sample, but you do not know that what is T1. What is the relaxation, span lattice relaxation time of what is the relaxation rate of my sample? So on the basis of this, I am saying that we take unknown sample. So I'm starting from the first sample, which is you've seen some of their relaxation curve of FC data of last day of these samples, and today I will present the time domain data of these samples. So I'm starting from the white cheese. So this is everything is okay. Our pulses length calibration is okay. Our tune is okay. Sensor, FID signal, everything is okay. So I will start from this, from setting the parameters. So then last time the people who delivered some lecture about the setting of these parameters, which is very useful, and I will also repeat some of thing, and some of thing I will show you. So here we have take care of the units. The first things we must take care of units, because if you have idea that my observation time is let's suppose 3 seconds, but here you see has written is microsecond, so you must take care of these things. Here also see microsecond. My conversion of the unit from second to microsecond, this is you must take care of these things. And here you see microsecond, but in the relaxation period you see millisecond. So first to take care of these things. So these are uh, I will randomly first I will check that what happened if I have unknown sample. I do not know the observation time. I do not know from where I will start. If I do not know the time T1, so I will put a random value. So like taking this value, I'm taking here initial value, final value, which is 3.5 second. And initial is 0.004 second, and then I taking T1 anticipating time of 0.045. So, and we know that the relaxation period is 5 times. We will take 4 times, 5 times. Around this, we will take this. So, taking 5 times of that, we will put here an amount of scan. I'm starting from 2. As you have the idea of our previous lectures that if you receiving some noisy data, and your the final curve is not good, so you have 2 options. You can increase amount of scan, and either you can increase the signal gain. So, but first of all, this is unknown sample. We do not know what will happen and whether what is our what will be the results. So let's go with the same setting. So I will apply, everything is okay, and then I will start the measurement. So okay, so this is our first measurement was done, and I will now go to the fitting. Unfortunately, here we see that this software sometimes not behaves, sometimes have some problem like uh, they are loading or something. So this time the same things occur here, but I will show this thing in origin because we have two options. The first option we have we can fit here, but if we do not have some problem with this is advantage, but you have the option of origin. You can go take the data and go to origin. From there you can fit the mono exponential, double exponential. So I'm saving this data, and this is my white piece with T1 value T1, and the range is 3.5 seconds. So this is my first experiment. So you see, if I will add something here. If you see that this lines, this equilibrium, the supplementary equilibrium is very long, means very high. So you have to cut this. And sometimes you need to show the few things I will add here. If you want to see that what's happened at the lower component, so you have two options. The first thing is you will, like I'm doing here, you have to decrease the time observation. And the second thing is you can also increase the number of points. So which I'm not doing because let's first take the example of because number of points, it will take more times. So we will first taking the example of reducing the time of observation. Let's run again. Okay. So this is, you see, it's now more clear. Still, if you want again, you will also, you can change from here that I'm taking 2 live and run. Okay. It seems no, the things we see, but you must, the best example, the best measurement is that your oxygen go to equilibrium and this lines go straight, become the, so this will be the perfect example. No, sorry to, because I need the fitting curve here to show something about the amplitude. So I will restart my setup. So this needs sometime refresh happen with software. So okay, so let's load our finding to and see what's happen here. So it might be centralized. So I'm restarting because I turn off everything. So I'm restarting everything and see what's happened. So I will apply, I will be, if it's the signal, we will be do again to refresh, and then unless we got it at center, so I will be run it again. Okay, no, it's okay. So I will apply, close. So when you apply, so it's sometimes update the frequency. Here you see, no, it auto update the frequency. Okay, no, again I have my FFD signal is okay, I see here, and then I will go to measure T1. Where everything is okay, I used last time, and apply, save, and let's go. Because my fitting option was not working, so that's why I restart my. Okay, so this is my another result. No, it's working. It's good. So I will apply here different type of functions, which is exponential, means mono, double, and other. So I'm starting from the mono. Now you will see that how it's fully fitted, it's diverged, it's not fitting well. So you will be see, the one thing is that you will be see the curve from naked eye. The second thing is that you will be apply double here, and we have the basic idea. If we divide the slower component by amplitude of slower component by higher component, fast component, and then if it's in percentage, if we see it's less than 10, so it will be mono. If it's greater than 10, so it will be bioexponential. So here, this is the one thing. And second thing, we will go to show this is by the mistake. So you will see that here the T2, but this is a mistake by developing the software. This is T1 value, by the way. So we saw here that we have the T1 value 0.43, and hopefully if we have time, then we will compare this value with the FFC data we have already Professor represented and Dr. Ella already have. So this is our first experiment for white cheese. We find the T1 value, and I will also save this result, which is seems a more accurate, more good one. Here I use 3 seconds. Now the second step, I will go to measure the span relaxation T2 value, and we will also see what's happened. So I will go to I use this. We have a very few application here because we have a new system. Few months ago, we use for hydrogen probes and fluorine. So we have the most we are using here application is this one, situation recovery, and the second one we use here CP mg 42. So I will use that CPMG to measure my okay. Now again, I will see what's happened to the signal. Gets out of S, so I will be correct the again. I will run again. Let's see now. Okay, so you can try, and here is the setting of these this to see this tune resonance. So we will increase how much scan you want. So if I did durations, amplitude limit, search range. So these are some things which parameter related to. So apply, and I will close. No, it's okay. So now I go again to the basic setting, and the only things, the parameter we will change here, we have two options here to set the measure set the parameter. The one is we can manually put the here echo time, or we can put the number of echo, we can put manually, but we have another option, which is auto option. We use this option when we put the anticipated T2 value, it will give us the time of observations, number of echo, it will automatically give us. So we have two ways to set the parameters. So I am using, and the other parameter we will change is if there is some noise, I already told you, if a noise in the results are, so we will use more scans. a good results, to get a good results. And the second thing is we can increase the signal gain. So I'm starting from uh, uh, 6 gain. Let's suppose I'm putting this random value, and the relaxation period we will, as I think somebody also told in the comments, uh, that we can use the relaxation period for T2 5 times. So I have already about some idea about my sample T1, which is 0.4. So I will 0.43. So I will multiply 5 times 2. So this is my relaxation period, and I told you we can use 2 ways. So the first thing you see here, anticipating T2 and millisecond, we enter with, let's suppose I change it. This is 800, I change it to 200, and I calculate. You see, this is observation times, uh, and real everything's are change. You can choose this way also. So let's I start from, because I told you before that I do not know about my sample, what's happening there, what is the observation times. So I will be take some random value. So let's take this value and amount of and you, when you click here, different some things which is related to this, you can change, will automatically change. And I'm taking some random parameters, apply here, and save. Okay, and put the 0. Okay, let run our experiment. What happened to the, so here we can set our, you see there is a very long component, means very long component. So you have to adjust, the parameters to get the exact result, because if you have the long component, this part we can't see what's are happening here. So this why we will change the parameters, uh, because this, okay. So I told before this problem, if anybody has some problem like the setting is not shown, so you can press Alt first step. So I do this, I see my setting. So now I will change these things, because we know you can adjust from here, from the start, from where you see that it's go to the go start to be decay, fully decay, go to 0. You can also cut from here, and this is observation time. You will set according to here. And second thing is, you can adjust by putting the number of echo of different things. So I'm starting from this part, the first way, because you see here in milliseconds, so I will goes to 0.5 second. So I will choose different value, at 600 millisecond. It goes to here. Let's see, we can check at this point also. But we after this is some random things which you will play with the machine with the your data setup. You can also use I will further show you. So I will apply here, and let's go what happened. Okay, so this something which if you unknown sample, you will play with that, and you will finally find your results. So next, I'm going to save this result. First close this. And first what's happened, it is mono or bio. We will first, you can see here, I have told you before that we can also, you see here it's not according to I will propose you here is two problems. The first thing is that this part is not clear, so we will reduce our time of observations. The first thing. The second thing is when I applying, it's not fully fitted, and similarly I will apply again, which is also not fitting. So it means that my uh, the time observation I took is not accurate, so I will change it again. Okay, let's go again to the auto, and where I will go to reduce this. I want around, see it start from here, so I need, let's see it at this angle, what are happening. If you want to remove your previous, you will clear fat, thing from here, and then you can. No, it seemed better, and we also have the first part we also seen it more clearly. I will close that and save my this result. Okay, I'm saving this result. This is like, I remove this. YouTube. Okay, because I will show you further. Okay, now we will go to the next sample, which is the yellow cheese. So I will request to my colleague to change the sample. So
okay, I changed. It's ready to measure.
Yeah. So few things I will propose to the audience is that if you are going to measure the sample at different temperatures. Let's suppose this time, and I took the sample from freezer, from fridge, and I put direct in the time domain, and I want to measure the at 40 degree. So you must wait for 5 to 10 minutes, or maybe more if you get high temperature, because the sample needs some time to adjust the temperature. So these things must be kept in your mind. So we with this sample we have changed its yellow cheese. It's already at room temperature, so we will not wait for so many time. If you take means I fresh sample from freezer, which is like at freeze at 10 degree minus 10 20, so it needs some time to come to the room temperature, so you must take care of these things. So now this is our another sample, so I will first go to check the FID, what is the signal response of our sample. And for this I will tune the resonance, what's happening, everything or in phase or not. So you see it's not adjusted. So I will just run again. Okay. Still we need some more. Okay. So it sometimes take more times to come in phase to head. So you will be repeat this step again and again. So just the frequency in the good range. So it's sometimes it's take more times. It's because the temperatures to get the uniformity in the sample temperatures. So the signal is not. So let's see. Okay. So this I see the other equipment using our collaborator party. They are good in signal, but our machines need sometimes. But this depend also the few parameters which can be interrupt in this centralizing. That is the first of all maybe the sample temperatures and the temperature which we are giving to from outside and inside temperature are not uniform, so it may be interfere this and maybe um, this is the main factors. So there may be also some other factors, but you can I told you because you will give some times to sample to get the uniformity. So I'm also today showing you some what you say drawback or what you say the most hurdles which come in performing this time domain experiments, which I get from my experience, from some other colleague experience. So this can be happen. So we found some of solution of them, and some of them we are still searching. So it's improve, but still it's want to become. Okay. So you see here our frequency is 18.53, which is seems to not too much difference. So I'm taking this. Okay. Let time check that. Sometime it's auto updated, but sometimes it's take the time. So this is maybe not the difference may be due to some sample, but it's not too much. This is 0.00 something. So but we will see randomly that it not so much far away from the central from zero line. So okay, let's go to the I will lie and close this, and then I will go to T1, measure the T1 of these yellow cheese. So let's XY plot and set the parameters. First of all, I will apply the same parameter which I have used for the white cheese. So then I will see what's happened. Okay, you see that we need to cut our result, and here which is info, this is some noise. So like we do not need this part, so I will reduce the final observation times up to 1.2. So it will be like, let's take 15, yeah, 1.5 second. Apply, and then I will run again. Okay, so you see this is up to some extent a good result. So I will now apply same way fitting. What's happened in fitting, you see it's not fitting well, so I will apply the double. It seems more accurate. So now I will save this data, and we will further this component. What are the component? What's their value? I will go to present in the origin file. So this is our yellow cheese. Okay. So now go towards similarly like for the first sample, we will go to the T2 value. Here first, I told you that if you want to not see the data and their fitting curve, you will like from clear from here. Okay. Now I will also again check what's happened after applying this CPMG. So, and also see our signal are stable or not. So I'm also checking again what happened. Okay. So like same, it is approximately in the phase because it 18.53 something. So, and we seems that's at in center. So you can to do more repeats to get more and more accurate. So, but it's here it seems to the center. So we will go with this value. Now go to the basic setting. And I will also, I told before in my first experiment that I have to adjust to this, the way I have learned this parameters, let go with this, the same setting and see what's happened and the result. Okay, so this is a result which seems extremely good. So I will proceed with the easy result. I will save. First, I want to show which what mono or biospecials functions is working or here, which one is working here. So I will first fit the data. Again, we will receiving the same problem. Sorry for that. I'm trying to fix this problem of our software that which not give us the fitting. Sorry for that. Let's save this data. We will let us see in Origin. If somebody have any solution to this things which are occurring that fitting curve are not shown here, you can mention in the comments.
My only solution is to copy the data to another software.
Yeah, okay.
Sorry, it's not very constructive.
Okay, so I heard, and so I save the sample data. So now first steps I will take to forward to my colleagues to change the next. We have two more sample, which is very interesting about the pure chocolate. We have taken the example of pure chocolate, which is one of them is cocoa 60%, 70%, and the main concentration of the second one is 61%. So I will refer to my colleague that change the sample, put the 70%. When the sample is okay, let me confirm. Emil Cobra, this is student from Turkey, so let me confirm us that the sample is changed.
Yes, it's ready again.
Okay, thank you. So as I told before that we must wait for some time, so adjust the temperature around the sample. We will also go again to see our 5D, what's happened with the changing of the sample. But we must, for this, because this sample was also at room temperatures, so hopefully we can wait for 3-4 minutes. The temperature will adjust, so after that we will go. Some people give me this. There is also you will must see the signal of gain, which can also affect if it's high. Because I told you that if you have some noisy signal and you want to have a good signal, have a good result, not a noisy result, so you can change two parameters. The first one is the amount of scan, the second one is signal gain. So I will check. I will check here. This is it. So I will check from lower. I will also maybe if the lower is helpful, so we can also produce. We can also follow this. That's 4. Okay. So these are some things which I deliver you, the parameters, the uh, cycles which come and the way if you are not getting a good results, so you will change these things. So let's the sample hopefully it will be, but it will be because I kept at room temperatures, so it is always room temperature, just 3-4 minutes it will adjust. So I'm going to first check the signal, what's happened there. Let me finish this. Yeah, it seems to some extent okay. So then centralize, close. Now I'm going to measure T1 value. And I also check the signal. I can repeat this again to confirm it again. So I will go to resonance. I can run it again after changing. And one more thing you see here, that I do the 50 FID. It's okay after changing the sequence for situation recovery. So it's again this is disturbed. So it means that you must do this tune resonance after changing each sequence. So here I will run it. So you see here low amplitude. So and so they give me questions. So I will increase the gain to 6. Let me. So you have to play with this to get the exact signal. So LC it's not same. So it seems now better. So I will apply, run. So it's depend, because this is chocolate. So we have experienced that I have some already some FFC result of this chocolate, and where also we seen some noise. We applied different uh, different. I applied different parameter. I changed different parameter. I increased the number of scans for this chocolate, but since we not getting, we have still some noise. So this depend upon the sample. If sample have more hydrogen, more proton, so you have a good results. So we are using the hydrogen probe, so that's why we are detecting these materials. So this it means these sample have less proton, this have less hydrogen. So this why you will see the noise and signal also in your result. So let's go further for the setting the parameters. So here I will also uh, apply the setting I already for cheese. So let's see what happen. If it's not in range, I will change further, and the amount of skin I use here too. Let's see, as we already also done for an unknown sample. So I do not know what is that time of observation for this sample. I do not know what is the T1 value of this sample. So I will repeat the same things if I'm using the unknown sample. Okay, you see, it's not saturated. It needs more. We need to increase the time of observations, because it is not fully. It needs some more times to here such a go to equilibrium. So we will increase here up to 4. Let's see what's happened. So again, it's not saturated, so we will be increase more and more. So the main things, you must have the idea about the basic idea about that, because every person have measured their own sample, but how to run, how to operate, which parameters are very important, and what are the how to fit and how to analyze the data. And to measure this chocolate sample, even we work very hard in FFC, and we change different parameters. We are still fighting with these samples, because seems again say that I'm not to equilibrium, so we need that. Let's move to the 7. So you have to play for an sample to see what's to when you get the value of time observations, everything. So then you can, using these basic, and further you can move, you can measure for different temperature. because you know that if we increase the time of observations, absolutely it will take more time. Yeah. So few other parameters, by increasing them you can know it seems that I'm near to saturation, so I will increase 0.5. So I was telling about that your measuring time will increase by increasing your amount of scans, time of observation. So these are some common things that happen with the experiment. So one thing you people see here, this is machine error. This is the first point which is not in the patterns, which is first. So we do not see that when we are plotting the origin, you will see there what actually happened to the sum. Very long observation time for this sample. So patient. It seems to some extent better, so we can take this value and let's see, apply the fitting. So I told before that fitting is not working, so I will save this value for this sample. So T1, this is 9 seconds. This the sample is 70%. Chocolate, okay. And start it. Let's measure the T2 value. Again, I told before that I will check what's happened to signal by changing this or sequence. That seems good. So the amplitude, you see here, density is varies to sample to sample. So, but if it is a central, it's okay. So the resonance signal must be in phase. It must be in phase. If it's in phase, then okay, we will proceed further, close and set the parameter. Again, the things which I always Okay. So now here I will use similarly I use for the other sample. This is 360. So I start from, let's suppose, from 80, calculate, and let's go to apply and run. Yes, this are very good. Another things which are happening here, and uh, I will also show that if such a things are happening with you. You see here there's a very noisy result. So here two things we can change to reduce this. First of all, we will change the scan. I'm using here 50 scan, let's suppose. Even you go to 100 different things, you need more scan to do. The second is the signal gain. So yes, I will increase this, or you either increase one of them. Okay, apply, and here I will use, I increased again, so I will not increase too much our amount of scan. I increase up to 20. So let's go with the setting. What's happened, we will see. And second thing, you see that the component is very large, so I will also adjust this time of observation for that. Because I told before that when you increase the amount of scans, it will take more time. So that's why this experiment take more time. Still, you see that we not satisfied from our result because it's also still noisy. So I will go to 100, scan, and then I will run again. What happened? So you see the result are going better and better and reducing the noise. You must be manage these things, these noise from here. Further, if you take such a result which are noisy and you going to plot in origins, so the same is look not very good. So too good to get a not noisy. You must manage here by changing the amount of scan and the signal gain value. So I increase amount of scan 5 times. So if before it take 5 minutes, no, it will be take 25 minutes. Let's suppose, which will not be happen here, but maybe 10 minutes, maybe 8 minutes. So these are the some things with when you are using the time domain, you have test some different type of samples. So these some obstacles, some things which happen to you, you have to manage to get a good results. So some of I explain and start, and some of and T2 measurement, T1 measurement, and during T1 measurement, and what you can face while measuring the T2 spin relaxation. So we are still waiting for our result. So fully, I think I will proceed with these three results, because if we go to the other some example of, so we have the time limitation, so it will be good that I will reduce to by with these three example of white, yellow, cheese, and the 70% hummus chocolate. Yeah. So you see that the result is getting better and better from the last time in which I used 20 scan. And you will also see the difference of these. Okay, so it's completed. So you can because still they have some nice, so you can also uh, the reduce it. The one more thing is that I will share with you, because I'm using here two sequence. One is CPMG. It's also very that because I'm here that fighting with the increasing the amount of scan. Uh, so you can also use different sequence for, because so far what we have these which we are using. So as I am giving some general idea about how to run this equipment and how to analyze the data of the sample. So in detail, if you want, you can use different sequence for solid, for others. So it's depend upon your sample, which in short time can give you a good result. So uh, I'm saving lack of time. I send the same results, and I will move to my next section of analysis of the TD data. So this is the T2 value of this experimental part of my this talk is finished. So now I am going to show you the results we have. Okay, let me start some. I will I have all these results. So every person have different approach to use Origin to open the data files. The short one I use, like I copy all and I bring here to Origin. So you can open from here, but I use this approach. Okay. So all of data I measure. So now I go to analyze, how to plot, and then analysis of this data. So taking start from the uh, this white cheese, we will try to, because we have different sample. We have, when we have chocolate, and you know what's the time of observation for the chocolate, and you know what's the time of have different t1 values. So that's why I will first I will combine them in a one plot, then I will show you one by one. So let's take an example from our first sample. As you know that in our weapons and here is milliseconds, so we have to need to change this value uh, from millisecond to second. So I'm doing so there is, we have some short way we can do, like one by one by set column value, and you can, this is your column A, divide by 1000. Okay, you can apply, you easily converted. And the second thing is we have another option which I will come back to the original data, through which you can also do you can apply and one click to if what you want. So here you will go here, divide by a specific value which I am giving this, and then you will be go to input. What would be your input? So select column, you can select there, you had your all column are here, so you will select from here, and you will further, if you sometimes you have a lot of data, you have different temperatures, so you do not you don't have the times to go and every workbook and to change their values, so you can apply this way. Okay, so we have short so I will apply, because we have 2, 3, 4 result. I will apply this way. You can also, f of x is show the formula, you can like here, and I will do for the other here, like a divided by 1000. Okay, and here also a divided by 1000. I'm doing this because we have not too much result, we have few results, so we can, because I want to show the x's and second. Sorry, my connect. Okay, so the second thing I will go to normalize my vertical, the this y-axis. So I will do, sorry, I will go to normalize my y-axis, go to normalization option, and yes, divided by maximum value. I will input some, select some column, and this is other way I told you, but I will be a few, so I will go directly here. Okay. And the one thing, if you want that to show that your legends which show your karo, represent your karo, you can enter your name from here. You can just white comments, white, sorry, comments, what's your sample name? Like the white cheese T1, okay. So similarly, I am first taking the example of T1. So I will normalize that. Okay. And I will give this yellow cheese. So every person has different approaches. So the way I'm using yellow cheese T1, okay. And the third one is I will also normalize that. %70 chocolate. Okay. One value. So I think I press 0. Now taking starting from this one, first I want to plot this, okay, and then you can also do in this way, minimize, and then go to the second one and select them. I have experienced one thing because you see that when the cursor is here, you can not bring it directly, but when you go here, you can bring it. So this is one more experience I can share with you. Yeah, I am taking this also. Okay, so these are our measurement. I want to change their color. First, I want to then and this, and then I will use different color. Maybe it will be better I use this shape. Okay, so frame, need a box, okay. And the second thing, you can also there is different way you can also give here the name. You can also in the workbook, you can also what easy for you, you can do for that. And here is normalized magnetization. Because we normalize, so the unit is unit. So you can play with these to how which type of graph you want. You can set the scale by the value, but you have to plan. Similarly, has a lot of major text, so I want to reduce this. I will push that. Okay, so something you have to do, like I need up to 2, and this minor major tag will be inside. So there's some practice with the origin, so you can do. I do not want, so right. So now, or it seems better. So one more thing, I told you that because I use a different scale for the samples, so the two of them was nearly compared to one another. So, but because each sample have different time observations, so we must take one by one. So I will arrange this, and again I will set the parameters. So value difference is 2. I will take it 0.5. Okay, sorry, 0.5 is also taking 1. And the starting is, you see, it's, I will take minus 0.05. Now see what's happened. So you have to play to set the starting range and of vertical axis and horizontal axis, and what similarly for vertical axis, if you want it down, so you will, like, I start from 0.2. okay, so this is something. Okay, it seems now better, and I can, like, final value, which is, I will take 3.2. Let's see. Okay, it's more adjusted. Okay, and you can also, if you are adjust the size. So now this is my result. Now I will to analyze what is the value of T1, what is the relaxation rate. So I will apply both the exponential mono and bi to analyze in this software in origin. Okay, I select that. Sometimes it's happen like you have also a fitting curve, so you want to fit it again. So when if you not select from here, definitely which is already selected, it will be fit that one. So you must, what is your target? If I want to, let's suppose I'm taking this, if you want to fit this, I will select from here. If I want to fit this, I will select from here. No is the rule of the fitting. So we will go to analysis, from where we will go to fitting, and this is non-numerical. I will open the, okay. So this is in the fit 0, so fitting log. So here we have a lot of exponential functions, some function we have built by ownself. So this is mono exponential, this is by. First I am going to this one. Let's see what happened. It's totally diverse. So let's go to the second one. I think there is something. Let me set it again. Professor, you are here?
Yes, I'm here.
Yeah, there is something I think. One more thing is before going to the fitting, you must see our lower part. What happens sometimes we need some value which is like here one of the value which is disturbing our fitting, so we must mask such a value, so in future.
This is a very good point, yeah.
Yeah,
So look first what is happening.
yeah. So this is, let me, okay, I zoom out this is values. Okay, I do not want, I want here. And how do you will mask? Go here and right click and you have option of masking, mask. So it is no operating. So if first I want to disable, then I will apply again, mask, enable masking. Okay, so you will, let me, okay, when you do this, you can go to the workbook. This is workbook from White Cheese, so I will go there and see what's the value. I will note the value, and you will, and you can like take this your reader and note this value. What's the value of this, which is 0.004 and 0.7, and you will go to the book 0.06. Please help me, which one value was that? Sorry, I not remind. Okay, let's see again, because first time it's not. No, it's working. Yeah, the first
Because the problem is that the data is in red and the masking is in red.
Okay, so this is, yeah, I got. I was surprised what happening.
What is happening to you?
Yeah, I was surprised that both color are same, so this one. Yeah, so let's see again what's happened to our function. We have directly go here. It seems no done. Okay, so the status of fitting is success, and we will see from, let me change the color of this fitting black, and I will like, okay, so my first try I applied the manual and I see that my T1 value, and then by the way, I will also apply the second function, which is by exponential, and I will see what's happened there. So after seeing their amplitude value, their ratios, so if it is greater than 10, so we see that it is by. If it less than 10, so we can also conclude it. And which from necktie we can say, we can also see that what is what it is manual or not. If after applying it is fitting well to the curve, then we can also conclude this. Let me check the second function. If I want to apply the bioexponential here, let me change the color of this. I will take some other color. Let's suppose this one, and make, okay. So you see, let me also, so you see, now you see both are seeming that it is fitting well. So I also, this is also a question from you people from last two day discussion. So what you see, which one is good, which one is accurate from your naked eyes? Then we will go to divide the next step. So
They're
what's
the
yours?
same.
Huh?
They're the same.
They are the same. So
Yeah.
yeah. So this is the way which you can analyze your data. You can apply the functions. So you can choose mono or extend one of them. So and the way the how you will select if it's which one is fitting well, you will select. The simple way is that the other way is that you must divide the slower component divided by higher component if the ratio between these two component, if it is by exponential. So we will check this, it's greater than tens in percentage, so it will be by less than. So this is some general concept about. So similarly we will go to our next fitting, which is next sample fitting. Let me set there and the size. Okay, and I will rearrange this and because we have to give some 15-minute to question also, so I am going to just apply the fitting. Use here. So origin, in origin you can use some shortcuts, and you can how much is depend upon your experience. So with practice you can save your time. This is, let's suppose I'm taking this black and okay, I'm going to apply the by exponential. You can also use this option. This is shortcut, so you already, but you must know that last time I used this, what you are going to apply. And let's like last time I use mono exponential, and now I want to get by exponential, so it is not good things to use this one. So I will go to proper way. So here I will apply this functions. Okay, so here you see that the by exponential is more good than mono up to some extent. You see it's like, and when you see the, it is in the center, yeah. So you will decide from this way, as much I told you before, that what things you keep in mind to select this identity. And similarly we will go to other parameters. T2 will do the same thing. And this is, I take one of the example. Let me plot T2 of one of the sample just to see. Yeah. So similarly I will also normalize this. Okay, and I will give the name here. sorry, T2. Let me plot this. Okay, this is, let me arrange that sec. So as the lack of time, I just come to the point you already told this about it, how to fit where the option, which option I will use. Let me check first mono exponential and then I will go to exponential function. Okay. But again, problem with curl, I will change the color and okay, you see still something is missing. If then we will do the same things, we will be repeat here if we not satisfied with this. And first of all,